Hello everyone. My name is Khushi Pendhari. Good afternoon. So today's webinar topic is about smart infrastructure engineering 2025. Means what we have to be seen in that session or in that webinar is about what is the smart infrastructure engineering of which used AI driven designs, simulations and the field automations. So why it is important, what are the main benefits of it that we have to be seen in that. So first of all is about agenda, means which points we have to be discussed in that session. First of all, it is introduction. We can see what is the introductory part about the smart infrastructure engineering, why it is important, what are the benefits of it that we have to be seen after that. Then key digital tools in smart infrastructure, means what are the digital tools we have to be used to make the infrastructure or the technologies in a smart way. After that, AI driven designs and the simulations, means how we can use the AI driven designs and the simulations to our designs and in our infrastructure so that our technology becomes smart. After that, field automation and reality capture. Then engineering dashboard and analytics, means what are the important factors that will be affected in the engineering dashboards or why it is important in the engineering fields. And then we will be conclude this session. So first of all is about introduction. Um, what is a smart engineering? This is one of the technology that we have to be seen in for the future generation. So first of all, in that, what is say that use of intelligent digital system to design, build, and manage the infrastructure. Means what? Modern civil engineering relies on a smart digital system. Means in olden era that we had used many olden techniques and that are very delays or any kind of giving us more time for the work completion. But in modern era, we have to be use smart digital system that automate, optimize, and the improve our the project workflows. After that, this system what includes? It includes AI based design tools, BIM platform, sensors, drones, cloud softwares, and all they are working together to ensure the efficient execution of the infrastructure projects. Why they help in what points they are helping in? They are helping to reduce the human errors. After that, they improve the accuracy of the design and the construction. After that, they streaming communication among the project teams. After that, they are monitoring asset condition throughout their life cycle. So in short, it is a digital system that creates connected, automated, and the data-driven infrastructure environment. After that, integration of AI, IoT, beyond drones, and the analytics. Smart infrastructure integrates multiple advanced technology, just like a AI for practice, analysis, optimization, and the automated design workflows. After that, IoT sensors means what? For the real-time monitoring of the bridge, roads, buildings. After that, BIM, Building Information Modeling, for the 3D, 4D, and the 5D project ordinations. Then data analytics, for the insight into the performance, risk, delays, and the cost. They all combine this technology to create a holistic digital ecosystem that improves planning, construction, operation, as well as the maintenance. Next one is about they are focusing on the efficiency, accuracy, safety, and the sustainability. So efficiency is a digital tool that reduce manual effort, speed up the design changes, automate the calculations, and streamline the processes. After that, accuracy, beyond drones, digital tools, and the advanced simulation ensures precise modeling and the real-time updates. Next one is about the safety. Safety is IoT sensors detect structural weakness, drones performs remote inspection, and AI predicts potential failures. And last one is about the sustainability. Energy efficient planning, reduced material waste, data driven environmental decision making contribute to the greener infrastructure. So, what are the core pillars of the smart infrastructure? First one is AI driven design and the simulation. Means artificial intelligence transforms engineering by running the simulation faster and more accurately, providing optimized structure and hydrological designs, predicting risks such as the flood, failures, and the traffic conditions, reducing design time and the automatic repetitive tasks. After that, BIM based coordination means integrated 3D models for the architecture, structures, MEP, clash detections to prevent the conflicts before the construction, centralize the documentation and version control. And last one is about that they are giving a real-time collaboration across all the teams, means fewer errors, fewer changes, and the faster construction. Then digital twins for the life cycle management. Digital twins is a real-time digital replica for the physical assets, bridge, roads, buildings, which is continuously updated with the data with the IoT sensors, BI models, and the field operation. They includes monitoring structural health, predicting maintenance requirements, tracking construction processes, performing simulation during the design and operations. And field automations drone mapping is about drones for surveying, 3D mapping, inspection, volumetric analysis, robotics for the site monitoring, automated tasks, GPS and laser scanning for the accurate field measurements. The last one is about data analytics and dashboards. They are visualizing project performance metrics, real-time dashboard for the cost, schedule, and the resource tracking, predictive insights for the decision making. Next one is about impact on civil engineering. Means smart civil engineering or the smart infrastructure. What are the impacts on civil engineering? Better project planning through the predictive insights. It will give a smart infrastructure technology, which is AI, machine learning, data analytics to forecast project outcomes even before the construction begins. Predictive models like estimation, material requirements, cost overdues, scheduling, delays, as well as the detection of the clashes that are the historical data from the past project analyzed to identify the pattern that may cause risk. So that is why it impacts on the civil engineering, that it leads a better decision making to reduce the uncertainty in the work as well as optimize the resource allocation and the significantly more reliable project planning. Next one is about accurate structural and hydrological simulation. Modern civil engineering depends heavily on the simulation software like ETAP, STAD, HEC, RSC, HEC, HMC, like that. Structural simulations test buildings and the bridges under the load such as wind, earthquake, and the traffic. Hydrological models forecast flood behavior, water flow, watershed response. Engineers can evaluate what if scenarios and improve the designs to it. After that, they enhance the collaboration using cloud-based platforms. This is what cloud-based platform like Beyond 360, Autodesk Construction Cloud, Bentley iTwin, and the Trimble Connect real-time collaboration. Like teams across the architecture, structural, MEP disciplines can view and update the same models simultaneously. Version control ensures everyone works on the latest drawing model. So this is drastically improves productivity, avoid clashes, reduce rework, and ensures seamless coordination between the teams. After that, real-time field monitoring and progress tracking. Using drones, sensor, IoT devices, and the mobile apps, field data are captured and sent instantly for the engineers and the managers. Drone provides aerial mapping, site inspection, volumetric calculations, progress photos. IoT sensors monitor concrete curing, vibration, temperature, structural strain, and the soil moisture. Field teams can update data using mobile apps and immediate reflection in the project dashboards. Real-time insights enable quick decision-making, early detection issues, improved safety, and accurate process tasking. Means what? They are giving us real-time monitoring throughout the building infrastructure, like from planning to maintenance. Improved quality controls and the safety compliance. Means what? Digital tools also brings new level of accuracy and accountability in the construction quality and safety. They will be automatically checklist and digital inspection ensures work meets standards. AI-driven analytics identifies that detects early and preventing costly work, which will be doing a rework. Safety sensors and the wearable alerts workers to hazardous conditions, so that gives a very quality control and the safety compliance. So this is what that impact on the civil engineering. After that, importance of the smart infrastructure. Why it is important? It enhances the efficiency through automation, digital workflows, and real-time monitoring. Smart infrastructure replaces manual process with the automated digital designs, which helps to speed up the design, construction, maintenance, and automated workflows. Ensure faster approvals, accurate calculation, and the instance data updates. Real-time monitoring systems such as the IoT sensors, digital dashboard that will give us to enhance the efficiency with the digital tools. After that, improves safety with the AI-driven inspection, sensors, and the predictive alerts. Safety is one of the biggest challenge in the civil engineering. Why? Because smart infrastructure uses AI-powered tools such as a drone camera, IoT sensors. They will be inspect the structures and the construction sites without exposing workers to danger. So this is the main important part for the safety as well as for the civil engineering fields. It will reduce the project costs, delays by minimizing errors and rework. Traditional engineering workflows often suffer from the conditions or the coordination errors that design clashes, miscommunication, leading to expensive rework. Smart infrastructure tools like BIM, clash detection, softwares, digital tools identify design conflicts earlier in the planning stage. Means you are designing a project, it will be predict some clashes before the project begins, and this will reduce as the mistakes, eliminates unnecessary works, and ensure better resource allocation. After that, it enables the better decision making with the advanced analytics and digital tools. Smart infrastructure produces large amounts of project data which can be analyzed using AI dashboards, digital twin platforms. Engineers get real time insights into the performance, risk, and future behavior of the structure. Digital twins simulate what if scenarios due to this. Then facilitates collaboration across the team through the cloud-based BIM platform. Smart infrastructure relies on the cloud-based environments like BIM 360, AutoCAD, Autodesk Build, or the Bentley systems, where architects, engineers, and the contractors can work simultaneously on the same model. Everyone sees live updates, reducing confusions and the communication gaps. This cloud collaboration ensures transparency, improves coordination and among the disciplines, and support the remote teamwork. Provide accurate simulation for the hydrology, structure, and the environmental impact. Tools like HEC RAC, HEC HMC, ETABS, Open Roads, and the environmental simultaneous play a key role in predicting real-time behavior. This simulation helps engineers assess flood risk, load-bearing capacity, soil behavior, traffic flow, and the environmental impact of a new project. It will be strengthens asset management and a real-time condition monitoring for forecasting. Infrastructure assets such as a bridge, roads, dams, pipelines are being monitored throughout their life cycle. Smart infrastructure uses IoT sensors, digital twins, and the predictive maintenance. So this is why smart infrastructure is important in today's generation. Next one is about target audience and like for which we can be given this webinar, or what points we are focused on it. So basically the target audience is about the civil engineer students. We are greatly benefit from understanding how smart infrastructure tools are shaping modern engineering. This will introduce them to emerging technologies such as AI-driven design, digital twins, BIM coordination. After that, professionals and planners like a project manager, civil engineering professions, urban planners, and the smart infrastructure technologies to use work efficiency. Next one is about the architect and consultants. Architects and the design consultants can be leveraged smart infrastructure solution to improve the coordination with engineering team. With BIM based platforms, clash detection, real-time updates, digital twin models, architects gain more control over indisciplinary collaboration. After that, BIM and GIS learners focusing on the building information modeling as well as geographical information modeling will gain insights into the advanced digital tools and modeling. Focuses on BIM and GIS integration, means building information provides detailed structural and the architecture information, with the GIS geographical information system provides real-time geographical, environmental, and spatial context. After that, AI assisted design, artificial intelligence enhanced civil engineering design to analyzing complex data set and suggesting optimized solutions. AI tools helps to automate repetitive tasks, perform clash detection, optimize reinforcement layout, predict failures, and generate design alternatives. Digital twins are virtual replicas of real-world infrastructure, bridges, roads, buildings, dams, and utilities, updated in real time through sensors, IoT data, and engineering tools. Cloud-based collaboration, which is BIM 360 Autodesk built for designers, engineers, planners, contractors, and the client can access updated models, drawings, and data in such a single device. And last one is about the sustainable planning. Sustainable infrastructure focuses on minimizing environmental impact, conserving resource, and improving the resilience against the climate change. So this is what we have to be focuses on. Learning outcome, participant will understand digital workflows for the smart design. Means how BIM models replace traditional 2D drawings, enable real-time updates, error-free coordination, the flow between the survey or the GIS data, 3D modeling, simulation, and the documentation. After that, how tools improves the efficiency. Mean BIM's tools like a Revit, Tekla, Open Roads automatically generate 3D models, schedule, quantities, and the drawings. Structural tools such as a StatPro, ETAB, Midas automatically check load, stresses, and the safety factors, as well as the hydrological tools like HECRSC performs automatic flood modeling and generate elevation maps, risk zones, and the flow simulation. After that, how digital models reduce rework, detecting clashes between the structural and the architectural, as well as the MEP component. How drones cut down surveying time from the weeks to hours. How dashboard track cost and performance, make schedules, make progress in real time and avoiding delays. Then simulation driven planning is about how the hydrological simulation, structural simulation, or the environmental solution which analyze air quality, water flow, strain, then flood level. After the structural simulation, building bridges, foundation under the loads like wind, earthquake, seismic, just like that. Next work, Trends in Civil Engineering 2025. Participant will be insights about emerging technologies, about transforming the industry like AI-assisted design, drones and reality captures, automation and robotics, cloud or collaboration, as well as the BIM and GIS integration. So the tools that we had used for the smart infrastructure planning is first one is about the BIM 360 or the Navis work. It enables the centralized project collaboration throughout the cloud-based BIM workflows. BIM 360 provides a cloud platform where all the project stakeholders, engineers, architects, contracts, and the planners can access the latest models, drawings, schedules, and the documents. This eliminates confusion caused by outdated files and ensures everyone works on a same version. Like cloud collaboration speed up the decision making and improves the project coordination. Next one is about supports clash detection to identify and resolve design conflicts early. Naviswork is widely used for the clash detection, which identifies conflicts between the architecture, structure, and MEP elements before construction starts. For example, if a beam intersects with a duct, Naviswork highlights the issue and we can resolve that clashes to reduce the delays and prevent rework. Next one, it provides a real-time updates for the drawings model and the construction data. As soon as designers update models in Revit, Civil 3D, and the BIM software, the changes immediately reflected in the BIM 360. Then enhance project documentation with the version control and issue tracking. BIM 360 keeps every version of your every file. This helps to lean teams to track what changed or who changed or and when it changed. So this will improve the communication and accountability across the team. Allow 4D and 5D simulation for the scheduling and the cost visualization. Naviswork allows integration of the construction schedules and cost data with the 3D models. How each activity will happen, how long it will take, how will it cost impacts it will be. Reduces reworks and improves overall construction efficiency by preventing design clashes, ensuring document accuracy and providing clear collaboration tools. Beyond 360, Navisworks significantly reduce on-site errors as well as the reworks. So this is how BIM 360 or Naviswork is used. Next one is Open Road Designers. For Open Road Designers is about for the next generation to civil engineering designs to ensure and develop the Bentley system. It unifies all roadways and designs to take one powerful environment, eliminating the needs of switching between the multiple software tools. It will cover horizontal as well as vertical alignments. Then road geometry, just as a curves, spiral, super elevation, 3D corridors modeling, cross sections as well as creating and editing in it, earthwork and grading, drainage and utilities designs, intersections and the road modeling. Benefits to engineers of that software is about faster creation, accurate roadway designs, automatic drawing and the model synchronization, ability to handle large scale highway, expressway and the roads. Next one is about Bentley software, which was we are using. Bentley iTwin is detailed software, like why it is used, or what are the uses that we had be seen in that. So Bentley is used for a platform for creating and managing digital twins of the infrastructure assets, engineering models just like a BIM, CAD, GIS, construction sequencing, maintenance history, real-time sensors data, geospatial concepts, as built and the operational records. iTwin enables a complete life cycle review from planning, design, construction, operation. This will help engineers and contractors to and owners to gain completely visibility into the performance, condition, and the future requirements of infrastructure. Then real-time visualization of the design, construction, and operation data. It will be gives real-time visualization by the softwares like Revit, Tekla, Open Buildings, Open Roads. After that, GIS data like ArcGIS, real-time captures by the lidar, drone, IoT device readings for the temperature, vibration, and the flow. After that, it improves the decision making through accurate and synchronized project information. iTwin aggregate that align data from the various engineering tools from the stakeholders and workers in a one centralized source of the truth. It eliminates the outdated and inconsistent data, speed up the design reviews and approvals, provides reliable insights for the project planning, helps to detect the issue earlier, reduce rework caused by the miscommunication. It will support the collaboration across the discipline with the cloud-based integration. It enhances project monitoring with the IoT sensors and the fields. Just like that, in Bentley, iTwin can connect IoT devices placed in a real-time infrastructure such as bridges, roads, tunnels, dams, buildings, pipelines. iTwin can be read live data from strain gauges, temperature sensors, vibration sensors, water level sensors, load monitoring devices, smart construction equipment. This enables real-time condition monitoring, predictive maintenance, early warning alerts, better safety management, and reduced maintenance costs throughout the data-driven actions. It will support the construction sequencing simulations as well as for advanced analytics, reporting, and automations. Next software is about the Tekla, industry-leading tools for the structural modeling and the detailing. Tekla structure is one of the most powerful building information modeling that tools used by the structural engineers, fabricators, and the contractors. It supports the creation of the highly accurate information, rich 3D models, or any type of structures, building, bridges, and industrial plants, and more. It is widely regarded for its ability handled extremely large and complex structural models, high accuracy in representing structural behavior, geometry, and the construction details. It supports accurate steel, concrete, and rebar modeling with the high precision. Tekla structures enables the engineers to model every component of the structure, including steel beams, column, bolts, plates, welds, concrete walls, slabs, beams, foundation, reinforcement bars, rebars, stirrups, meshes, and the couplers. Accuracy is extremely high because Tekla uses constructively modeling. It means all dimension, resize, connections, reinforcement are modeled exactly as they will be built. No assumptions and applications, errors minimization and during the fabrication and the construction. Next one is about generation clash-free construction drawings for the fabrication ready details. Tekla automatically checks for the steel to steel clashes, steel to concrete conflicts, rebar connection mistakes. Once conflicts can be resolved, the software generates shop drawing, erection drawing, bar bending schedules, assembly, and the part drawings. After that, it enables 3D model based on coordination and across the engineering and the construction teams. Tekla structure improves collaboration by allowing engineers, details, fabricators, contractors to work on the same 3D model for the clash detection and design review sessions. Integration with BIM coordination tools like a BIM 360, Trimble, Connect, Naviswork, and the Bentley iTwin. It improves the project accuracy with the data-rich constructible models. Tekla models are not just 3D shapes. They contain intelligence such as material properties, dimensions, weights, connection types, cost, reinforcement details, and the fabrication codes. This will help to improve the design quality, predict problems earlier, reduce errors in detailing and the construction, increases overall project accuracy. It will provide automatically quality takeoff, QTO means quantity takeoff, for the efficient cost estimation. Like Tekla structure generates accurate quantities directly from the model, like steel tonnage, concrete volume, rebar weight, weld lengths, bolt counts, formwork quantities that will be automatically taking off that quantities. Mean in short, it will be give a estimation automatically. Okay. So this is how the Tekla works, or the why Tekla is used. Next one is about Autodesk Build. Autodesk Build is a modern construction management platform that used to connect office teams, field works, engineers, and the contractors. It combines project management, cost management, and the field collaboration in one cloud-based tools. It ensuring the projects that stay coordinated, efficient, and the error-free. It centralized the platforms for the construction management. Autodesk Builds integrates all the construction workflows, documents, drawings, models, any issues, schedules, as well as the reports in one digital platform. This allows teams to work from the single source of the truth, avoid outdated drawings and the miscommunication, track construction progresses in real time, ensure smooth coordination between the design field and the management teams. It supports modern fields execution with the concentrated drawings and the models. Autodesk Builds provides access to the latest drawings, 3D BIM models, and the specification and on-site. Field teams always use updated and the corrected drawings. Reduces construction mistakes due to the outdated information. Models can be viewed on the tablets, phones, and in the field. It improves the project quality with the issue tracking and the clash-free coordination. While clashes are detected earlier during the design using Navy's work beyond collab, Autodesk Build helps to track and resolve these clashes. Log issues directly from the field, assigned to responsible engineers. It attaches the photos as well as the comments and the drawings. It will be monitor resolution processes. Fewer on-site errors, as well as this will be a faster issue resolution, better construction quality. Next one is about it enables creation and the constructible coordinated workflows. Although the Autodesk Build does not model steel, concrete itself, it ensures that constructible models created in Revit, Tekla, Civil 3D are coordinated and properly used in the constructions. Review coordinated 3D models, validate model data before the construction. Run checklist, inspection, and the quality test. It will connect the model's elements into the fields, tasks, and the schedules. It will be automated document and report generation. Daily progress report, quality checklist, safety inspection, RFI logs, submittable workflows, punch list can be automated, documented, and the report will be generated automatically. Next one is about it supports different types of coordinated models which are clashes free. It will give automated fabrication drawings, means suppose if you want any drawing or like that, you can get it from that. It enhances coordination and the cloud based field connectivity. Because of that, cloud based and accessible from anywhere, available to any mobile device, it will be gives a high quality. So this is how it will works. Next one is about the drone deploy or the Pix 4D. It will be leading platform for the drone mapping and the 3D reality captures. Drone deploy and the Pix 4D are industry standards tools like for converting drone images into the accurate geospatial data. They allow engineers, surveyors, and the construction teams to capture real-world site conditions quickly and more cost-effectively. High resolution aerial imagery, accurate geospatial mapping, cloud-based data processing and the sharing, integration with the BIM, GIS, and the CAD software. It will be generates orthomatics, cloud point clouds, 3D models, and digital terrain maps. These software platforms processes drone images into the several useful outputs like orthometric maps, high resolution GIS, accurate aerial maps useful for the site planning, inspection, and the documentation. Point clouds, millions of geo-inferred 3D points used for the terrain modeling, contour mapping, and the digital twin. 3D models helps to visualize site conditions in a realistic 3D environment, useful for the presentation, stakeholders, and the communication for the planning. It will support the precise surveying, topographical mapping, and the site monitoring, accurate land surveying, preliminary site investigation, contour generation, slope analysis, elevation measurements that will be done by drone-based surveying increases safety by reducing the need of engineers to physically assess the hazardous or the hand to reach areas, help track construction progresses through the periodic drone flights like weekly or monthly progresses, work completed versus work plan, it will be give you. After that, material takeoff, earthwork status, and the site safety conditions that will be given by a software. Useful for the volumetric measurements. Like that, one of the most valuable feature for the civil engineering, like stockpiles volume measurements. Measurements aggregates like sand, gravel, soil, stones, highly accurate when the compared to manual or total station methods. Cutoff field calculation. So basically how we can find it out, the cutoff field calculation. So by that software we can get more and accurate results, like calculates how much earth needs to be removed or how much should be added. It will be essential for the road work, site leveling, and land development. After that, material tracking reduces loss, theft, and the miscalculations, supports cost estimation and the billing verifications. And last one is about what are the benefits for the civil engineering on the construction industry for of this two of that software. It will be faster data collection up to the 10x faster than the manual surveys. It will be reduce the manpower and the operational cost. It will give a better visualization for the communication with the clients and the authorities. It will increase the safety and reduces on the ground risk. It supports digital as well as creation and integration data drawn from the BIM and GIS. And last software that we have to be seen about HSC RSC and HSC HMC. This is what it is, river analysis system or the hydrological modeling system for the powerful engineering tools developed by the US Army Corps and for the engineers. They are used to water flow modeling, flood analysis, storm water studies, and the watershed hydrology. Although the points you have provided relate more, that points that are provided are more related to the structural modeling. So first of all, we have to be seen about HSC RSC. HSC RSC or HSC RMC is what? It will give you a rainfall or runoff processes within the watershed. It also helps engineers to understand how much water will be flow into the rivers, lakes, and the drainage system during the storms. After that, key features: watershed modeling simulates for the rainwater runoff surfaces. It will accounts for the filtration, evaporation, soil moisture, and the land use. Then storm and flood prediction used for the flood forecasting, dam safety studies, stormwater design, helps to determine the peak discharge at any point in the watershed. Hydrological components, basin models like watershed subdivisions, meteorological models, and the control specification. And then river analysis system is what is it is used to simulate the water flows in the rivers, the canals or the flood plains. Means in each area the floods are more, so how the water flows that we have seen. What are the core abilities of that software? It is 1D, 2D, and 3D hydraulic modeling. Hydraulic modeling means watershed modeling or the flood analysis. 1D is about river channels, 2D is about flood plains, and 3D about detailed flood behavior, which is advanced cases. Floodplain mapping. It creates highly accurate floodplain using the terrain data, as well as it supports the integration with the GIS and the LiDAR. Bridges and culvert analytics determines how bridges, weirs, and the culverts affect water flow used for the structural clearance checks and the flood designs. After that, dam break analysis, it simulates what happens if dam fails, used for the emergency planning and the safety compliance. What are the applications of it? River engineering, beach culvert design, urban flood mitigations, hydraulic structure designs, flood hazard zoning. So that are the main important applications of it. Um, how it works together. Suppose that both software generates runoff hydrographs such as water flows, watersheds. They will be give a flood routing, storm water planning, dam safety analytics. After that, river basin management, urban drainage design. So that will be given by that software. So this is what we had seen, like which software are used for the smart infrastructure planning or why it is used. So now we are concluding this session. So what is digital tools transforming civil engineering? Smart digital technologies are dramatically reshaping the way civil engineering projects are conceived, planned, and deliverable. Such as our tools like artificial intelligence, building information modeling, drones, IoT sensor, GIS, laser scanning, and the advanced analytics provides engineers with the new capabilities that were not possible in a decade ago. Means, suppose in some olden times we are not possible to take a new advantage or the new technology for the future generation for, but now we can use that technologies, artificial intelligence, building information modeling for our future generation, which will be give a faster and more accurate designs. It will give a real-time monitoring of the site activities. It will give early detection of the risk as well as the errors. It will improve the collaboration among the teams, consultants, and the contractors. It will give a better visualization of complex structures before they are built. Means suppose you have one client and they have some imagination like I want that kind of structure. I want to build this type of things in my house, but they are not imagine just they are imagining. They are not going to understand what will be actual on the sites. So by that software you can their visualization you can create a 3D models, or you can create the things they are want in their structure. So basically it will be give clients more benefits of it. After that, why it is the importance of BI meta AI driven techniques in modern infrastructure, as we are growing in a scale as well as the complexity, such as the highway, matlab smart highway, or the metro systems, or the high rise buildings such as the tunnels, bridges. Traditional manual processes are no longer sufficient for that, because as the structure are begins more complex, the traditional methods are not being sufficient to handle out that kind of situations or clashes or any kind of thing. So for this you have to use some new technologies and new things. So the automation reduce repetitive tasks, it will minimize the human errors, it will accelerate the modeling, documentation, and the quantity calculation. It will be improves the quality control as well as the construction sequencing. Then we use digital twins for the future replica of the physical assets to update continuously with the real-time data. Like it predict the performance, identify the maintenance needs, optimize the energy consumption. It will simulate the changes before implementing them on a site. Then about the cloud platforms. It will give you a version control, instant sharing of updates, reduced delays due to the communication gaps. After that, simulation and AI based tools, means which tools we had to be used, like structure analysis, traffic flow predictions, flood modeling, soil behavior simulation, then cost forecasting, real time assessment. So that we had used for the simulations, AI based. The future of civil engineering and the smarter, safer, and sustainable. Because of that technology, our future should be smarter, safer, and the sustainable. So how it will be? How it will be safer? So first of all is about the hazard detection throughout the AI sensors, structural health monitoring, easy warning system for the bridges, dams, slopes, and the tunnels. Then smarter, how it will be smarter? Automated workflows, real-time dashboard for the project status, data-driven decision making instead of the assumption. It will give you intelligent traffic management and the smart cities. resistant, improved disaster prediction, robust structural design, adaptive planning, and the climate changes for the smart cities. And the sustainable, it will be reduced material wastage, it will be optimized energy consumption, eco-friendly construction method, and the long-term life cycle planning. So in that session that we had seen so many types of smart engineering processes, like why smart engineering is important, what are the uses of it, and how it will be used in our real-time monitoring data. So this is how we had seen. If you have any inquiry about the softwares, our firm is available to give you more information about it. ABC trainings, that is our inquiry number, and if you scan this code, you will be get information about the software, about the technologies, or the things that we are given. So this is how we can you can go here and see what are the softwares are available, or if you are interested you can contact to them. So thank you for the today's session. We are concluding it right now. Thank you.